In this episode of Hot Topics, a web series on thermal remediation, we'll be talking about thermal conduction heating.
What are you gonna pick? Hot Topics!
So thermal conduction heating is a technology that involves drilling a hole in the subsurface and inserting in that hole a heater. And what we do is we look at the treatment zone, and we divide the treatment zone up into a grid, a regularly spaced grid of boreholes, and in those boreholes in each of those holes we put a heater. And when I say heater, it is literally a heater. It's very similar to what you might have in your oven or the heating element on your stovetop. When we apply electric current to that heating element, the element will get hot. And for our heaters, though, that temperature is actually up near 1500 degrees Fahrenheit, or around that temperature. So why do we do this? How does this actually heat up the soil in between the heaters? Well, that's a process called thermal conduction. And the heat, or the energy that's released at the heating element, whether it's a gas or electric heating element, is directly conducted into the soil and the water via thermal conduction. At some point, there's also some steam generation, so we can get some convection of steam, and when we get convection of steam, we get condensation of steam, and that's a very effective way of transferring energy in the subsurface as well. But the primary mechanism is thermal conduction. And as that energy moves out from these heaters into the surrounding soil and water matrix, it heats up. Now, thermal conduction heating is similar concept to electric resistance heating, in that we're heating that soil water matrix, but it's fundamentally different. Those heating elements, because they're so hot, and if we put the spacing between the heaters appropriately and wait an appropriate amount of time, we can get the soil up to temperatures of 100 degrees C, like ERH, or even higher. To get it higher, we have to put in more energy, wait more time, and boil off the water that's present there. Once the water is gone in between the heaters or in the soil, then the soil can reach temperatures higher. What kind of temperatures? We can go as high as 300, 400 degrees C. That's been done many times, and it's been done to treat high boiling point compounds, for example, PCBs, PAHs, even PFAS can be treated at those high temperatures. In the next episode, we're going to be talking about steam-enhanced extraction. So this is John LaChance, and thank you for listening to my video today. Thank you for watching today's episode of Hot Topics. Please check back in the future, as we will be posting up additional episodes with new topics. And if you have a question or a specific topic or comment that you would like to share with me, I'd love to hear from you. My email address is jlachance@cascade-env.com. Thanks for watching.